Hello, everybody. So I want to talk to you about evolutionary architecture. And with evolutionary architecture, what we're talking about is how we can have the rigors of architecture, but still be able to modify our systems at the rate of change that our business users expect. So, as was pointed out, I'm working on a book with Neil Ford and Pat Qua, which will hopefully be out about the middle of this year, on evolutionary architecture. And so the first thing we had to do, of course, was to define evolutionary architecture. Now, I'm not going to try to define architecture, because that's just too hard. But if you want to think about architecture in the broadest sense, this is all of the structural things that you have to worry about as an architect. It's the illities. It's how we approach putting our systems together. But what makes an architecture evolutionary? Well, there are three components, and I'm going to focus really on two of them, because with a crowd like this, I think the incremental nature is probably something that you already understand. The first critical component of an evolutionary architecture is that it's guided. We have to decide up front what are the critical factors that are important for this organization, in this industry, for this system. Because not all systems need the same kind of architecture. I worked on a trading system once, and everybody hears trading system and they think low latency, high throughput, high performance. This particular organization, in their wildest dreams, assumed they would have 100 trades a day. Not an hour, not a minute, a day. They didn't care about lots of those performance criteria. They cared that they didn't lose a message, because each one of those trades was worth billions of dollars. So our architecture didn't look like a lot of architectures for most trading systems, because that's not what was required. So by guided, what we mean is we look at what are the critical architectural requirements for this system. How are we going to balance performance and security? What about our mean time to recovery? Which of those things are most important to us? And we make those decisions up front, and we keep revisiting those, but because that guiding function allows us to make decisions about when we pick a particular tool, what a particular tool should look like, how we might approach the application architecture of the system. So this guided nature is critical for an evolutionary architecture. You've also heard me mention several of these architectural dimensions, because we can't optimize for everything. Many of these architectural characteristics are, in fact, in conflict with each other. And so instead, we have to decide, how are we going to balance this? This is just a multivariable optimization function. We know about these all the time. We want to find a place where we get the right balance amongst those various architectural characteristics, and we're willing to take a hit on the ones that we don't think are as important. In the case of that trading system I talked about, we took a hit on performance because we wanted to make sure that we could trace all of these trades through the various systems, and we knew exactly where they were, and we knew if they got stuck. Because although they didn't have many of them, they did not want them to get stuck. So why am I calling this evolutionary and not incremental or adaptive or just in time? And you'll hear a lot of people talking about how architecture has to change from this process of building a 5 or a 10-year technology roadmap and marching resolutely down this roadmap. Lots of people have recognized, finally, I've been talking about evolutionary architecture for years, and finally people don't think I'm irresponsible anymore. They just want to know how to do it. But why is it evolutionary? It has to be evolutionary because of this guiding function. We don't want it to seem like it's ad hoc. Architects get nervous when they think decisions are being made in a random fashion. It's an architect's job to define what that guiding function is. And so, appealing to notions like evolutionary computation, we're saying we want our architecture to be evolutionary. We are going to define a fitness function, and we are going to evolve our architecture consistent with what that fitness function tells us is correct. As the environment changes, some of those decisions might have to change. As our priorities change, some of those decisions might have to change, but we have encoded in this fitness function what constitutes good. So, I want to talk about some principles of evolutionary architecture. What are some of the things that make an architecture evolvable? And the most important thing to start with is we need to care about evolvability. And I'm not talking adaptability. What I find very often when I'm talking to people is when they hear the term adaptable, they think, okay, somebody went into a room and figured out all of the different ways this thing could change. And we're going to build in all that level of adaptability so we can configure the system. That's not what we're talking about. We can't guess that well anymore if we ever could. We can't, in advance, know what the axis of change is going to be, what consumer-facing interaction pattern some random company over there is going to come up with, and all of a sudden you as a bank have to figure out how to work with your customers in that same way. We can't figure those things out anymore. So instead, we need to focus on evolvability. We need to consider that this is one of the ilities. Now, as an ility, that means it might be deprioritized. It might be you decide this system is simple enough that if I do have to change it, I'll just throw it away and rewrite it. At that same client I was talking about earlier with the trading system, they had a sandwich ordering system. And yes, it was a great perk to be able to, first thing in the morning, order my egg and chive sandwich. But the office was in central London. There were hundreds of sandwich shops within a 1-block radius of this office. So if the system was down, or if they decided they wanted to have a flashy new interface, nobody cared. You would just throw it away. So evolvability, just like all those other ilities, might be something that you deprioritize. I'm not going to worry about how easy this is to change, because if it has to change in a way that's hard, I'll throw it away and start over. So we need to elevate this notion, not of adaptability, not of configurability, but our ability to change the fundamentals of that system into a first-class ility. So the first step, as architecture, we need to think about what constitutes evolvable. How do we make a system more evolvable from an architecture perspective? I can't go into all the details, but let's talk about some of the things that you might care about. How are different parts of the system coupled? You'll hear a mantra very often, loose coupling, loose coupling, loose coupling. Some things should be more tightly coupled because of some of your other ilities. You want to think about what is the appropriate level of coupling. And that what is appropriate is very often going to be tied to things that are in the business domain, and I'll talk more about that later. And then what about data life cycles and data ownership? That might influence how you architect your system. With microservices, people talk often of exploding out their data into multiple data stores. Maybe that's the right thing for you, maybe that's not. I worked with one client, it's a Fortune 100 company. We had to go all the way to the global CFO to find someone who could sign off on our data migration, because data ownership was so scattered across the entire organization that you had to go up to the global CFO to get someone who had the authority to say the data migration worked. Now, the first thing he did, smart gent that he was, he said, I'm going to delegate that to this, and oh, by the way, we're going to look at data ownership because this is insane, which it was. The way those systems had evolved over time, you had all of this tangling of data ownership. We need to think about what data, how that data fits into our system. And it's amazing, even with all the talk about big data these days, people don't think about data architecture. They think about how they can use the values, but they don't think about what the architecture of that data should look like. We need to focus on business capabilities. When you think about how your users come to you to say, I need to change the business process, or this flow, or this interaction, they're not thinking in program terms. They're thinking in business terms. We need our systems now to reflect the business concepts. For years, we've been able, as IT people, to get away with making the business conform to the boundaries of our systems. The previous speaker was talking about some of these huge ERP systems and all of the constraints that put on the business. That was the right thing at that time, but we can't live with those things anymore. So when we talk and think about the architecture of our system, the application architecture, the data architecture, we want to do this from the lens of business capabilities, because these are the things that our business users move around in their heads when they're reimagining how they want their business to run. And if our building blocks mimic the building blocks that they have in their head, it's going to be a whole lot easier for us to compose those things and reuse them and move around that IT capability in the same way they're moving around that business capability. So we need to think about how we draw the boundaries. One of the things that was so easy in the past was the boundary was as big as we wanted it to be. Our ability to change things relies a lot on where we draw those boundaries. And that is going to be one of the more critical design decisions. Certainly in a microservices architecture, it is the critical design decision you make. How do I split this thing up? Acknowledging that sometimes you might need to smush it back together or split it up further. What is the granularity of the API that you're going to build? All of those questions need to come back to how do we think people will use this? There's a notion of consumer-driven contracts, which I think is really important. I loved the picture of the Soasaurus falling into the cliff that was shown earlier today. I think one of the ways that SOA went so horribly wrong is we didn't have consumer-driven contracts, we had producer-driven contracts. Those contracts were developed by the IT organization. This is what I want to serve up to you. Go forth and use it the way I want you to use it. Consumer-driven contracts turns that around, and it says it's the person who's going to use that who should dictate what the contract is. Let the people who are actually going to try to do work tell you how best your work can support theirs. Because at the end of the day, an API or a service is useless if nobody uses it. So we want to focus on these business capabilities. We want to think about drawing these boundaries in a way that makes it easier to move things around, to compose things in different ways, to change the order of things, to better support our business as their environment changes. Now, we don't just need to think about this from an architecture perspective. We need to think about this from a development perspective. And one of the things that we've learned is that evolvability of a piece of code or a system is very strongly tied to your ability to understand that system. And so this is where internal software quality matters. This is where caring about the hygiene of your systems matters. This is where knowing exactly what the configuration of your production environment looks like matters, because you have to be able to understand what's going on. So we're big advocates of continuously measuring software quality. Now, there is no magic number that says it has to be this floor of quality, because again, it depends on the program. We ran an experiment in Thoughtworks around our code samples that have been collected since about the mid-1990s. And we ran software quality metrics over them and found that for each of the individual problems, there was, in fact, a floor. You couldn't write anything simpler than a certain level, because if you did, you didn't represent the complexity of the problem. So you want to measure software quality continuously, but you don't necessarily want to do anything about it right away unless you see something dramatic happen. But you want to focus on the overall understandability of your system, because you can't change something that you don't understand. Being from Thoughtworks, I have to say testing. I have to say testing a lot because we're fanatical about testing. But one of the other things that we found is if you think about the architecture of a system, whether you're thinking of an individual program or an entire integrated set of services, if you think about how easy or difficult it is to test, you'll actually end up with an architecture that's pretty easy to evolve. You will have good separation of concerns, because if you're thinking about testing, you won't have a module that says, do this and this and this and this and this. If you can't succinctly describe something, it's doing too much. It will steer you away from putting too much business logic in places where it shouldn't be. We advocate smart endpoints and dumb pipes. It's very difficult to test business logic that exists in certain places in the system. You should stay away from that. Thinking about testability leaves you with an architecture that is, in fact, easier to change. That's partially related to what I was saying on the previous slide about how easy it is to understand, because those tests, by reflecting what it is the system actually does, allows you to better understand how your system is actually working. I knew the CEO of a medium-sized business in the UK who every week read through the acceptance tests for his product. And he said that way he could hold the marketing people accountable when they went off and said what his product did, because he knew exactly what his product did. They thought about how to test the system, and they wrote the tests in such a way that he, as the CEO, not an IT person, could actually understand what his product did. And he was really excited about that. Now, what about governance? In a traditional organization 20 years ago, you would have a central architecture group, and they would make all of the decisions about how systems were to be developed and what tools were going to be used and what the technology roadmap looked like. And all of the development teams were supposed to follow that. And we've been going through this shift over the last several years as things like agile software development has started to take hold, and architects are trying to figure out, how do I fit into this? How do I make sure that the things I worry about as an architect are actually reflected by the delivery teams? Because their purposes are in conflict. The delivery team's job is to make their business user happy, to get stuff out as quickly as possible to make their business user happy. The architect's job is to make sure that the overall enterprise value of the IT assets don't decline. He's got to worry about maintenance. He's got to worry about stability. He's got to worry about operations. She's got to worry about licensing costs, how I can allocate resources. Architects and developers fundamentally care about different things. So how is it that an architect, if we're going to devolve more and more decision-making to the development teams, how are they going to influence those decisions? And we do it through this fitness function, through this guiding function. The architect specifies to the teams, these are the things I care about. These are the things that are important in this system. Your development team has to make decisions within this sandbox that I've drawn. That's how they communicate the things that keep them up at night. This gives the development team the information that they need to make the right choices, and it takes away the need for the architects to have to guess. Because unfortunately, in many companies, architects are seen as overhead. And what do we do with overhead? We try to reduce it as much as possible. And so you'll have 1 or 2 or 4 architects trying to keep track of 50 or 100 or 1,000 different delivery projects. They can't do that. They can't understand enough about each one of those individual systems to be able to make those decisions. But they don't have to. If they say this is the criteria under which you should make those decisions, and then they hand it off to the delivery team. And then it's the delivery team's responsibility to make whatever the best decision is for them within the constraints specified by the architect. So architectural governance becomes a discussion about how we are matching our fitness function, how the decisions that we are making are consistent with the constraints that the architecture team has put out, as opposed to a checklist or a review of all of the different architectural decisions. So this fitness function that we talked about initially provides the mechanism for governance. And you centrally decide what's important and what that might mean in terms of decision making, and then you decentralize the decision making as much as possible. So that's that role that fitness function plays. That's also the place where you can have the conversation. Perhaps one of those fitness criteria has changed because of something in the business environment or the regulatory environment or an opportunity or a competitive threat. That's what governance should be about, not a checklist on whether or not you're running the right tool. So what's made this possible? And I'm going to make a pretty strong assertion that doing something like evolutionary architecture in most enterprises is irresponsible unless you have the discipline of continuous delivery. Because what continuous delivery allows you to do is make these kind of changes that are otherwise very disruptive. No one is at their best at 3 o'clock in the morning on a Sunday when most enterprises are trying to roll things out. I don't care how good the playbook is, it's going to be difficult to get it right. If we're going to be evolving fundamental aspects of our architecture, we're going to be taking risks unless we know that we've taken all the other risks out of that deployment. So the discipline of continuous delivery has made evolutionary architecture possible. We know we've needed it for a long time. Now we actually have the enabler that allows us to do it. So what does the future look like? Well, for one, people don't call me irresponsible anymore when I talk about evolutionary architecture, and I think that's really cool. They instead say, I know I need it, what do I have to do to make it happen? But we're in the very early stages of even thinking about, what does this fitness-driven governance look like anyway? How do I write a fitness function that reflects these ilities? Some of them are obvious. What kind of response time you want? What kind of recovery time do you need? How many transactions must you be able to support? But what's a fitness function for evolvability? So there's going to be a lot that still has to go on how do we think about explaining and defining our architectural requirements in terms of these fitness functions. I think there are also some interesting things around platform and API thinking. When I talk about evolutionary architecture, we are talking about incrementally building up a system. At what point do you start to say, this is platform or application? If I'm trying to do all of this on a pull mechanism, when do I make the decision about what actually has to go into that platform to enable it? There's still lots and lots of questions around how that interfaces with evolutionary architecture, but these are problems that we're going to have to solve. Platforms are becoming more and more common as a way for organizations to deliver value more quickly. And then, of course, artificial intelligence, machine learning, how does all that fit in? Are we going to get to the point where we're using a machine learning algorithm to evolve our architectures? I hope not. I don't think we're there yet. But how do we think about our systems in general when we're no longer in control? when we can no longer actually say this is the right answer? How might that apply in this fitness function thinking? So I think the future of evolutionary architecture is bright. I think this allows us and empowers us to build the kind of systems that our business users expect for us to build. Thank you very much.